Hi everyone. Today we're working on a coding challenge on LeetCode called TwoSum. This is a really famous coding challenge, and it's one that really every developer should be familiar with, especially if you're preparing for job interviews and things like that. This is a very standard interview question and one that everybody should really be familiar with. So we'll go through this today. And in this challenge, you're given an array of integers called nums and an integer called target. And you need to return the indices of the two numbers that add up to the target. And they tell us here you can assume that each input will have exactly one solution, but you can't use the same element twice. So it does need to be two different elements in the array that add up to each other. Okay, most real-world data will not be like this, obviously, but for this challenge, they are telling you that you don't really have to handle the exceptions. For example, an array that doesn't have a solution, or an array that has potentially multiple solutions. In this case, every array that you get as input right here will have exactly one solution, and you can return the answer in any order. It doesn't matter which index you list first. Okay, to take a look at our examples, make sure we understand the problem fully. Here's what an input array will look like: 2, 7, 11, 15. In this case, the target is 9. So the two numbers in this array that add up to 9 are 2 and 7, but do notice that you don't return 2 and 7. You return the indices of 2 and 7. So in this case, that would be 0 and 1. So jumping into the code over here, if this is your first time ever looking at this challenge, probably the most likely way that you might come up with this, if it's your first time trying to solve this, is what's commonly referred to as the brute force method, which involves using two nested for loops to go through every number in the array and compare them to every other number and add them together and basically see if they equal the target. So I'm going to start by setting up the outer loop, which is going to be let I equal 0, I less than nums dot length, I plus plus. So that will go through and iterate through each value in the array. And then what we need next is an inner loop, so we can have a second value to compare that to. And we want this inner loop to let j equal I plus 1, because we don't want to compare I to itself starting from the same number. We don't need nums at 0 compared to nums at 0. What we want is nums at 0 compared to nums at 1. So we always want this inner loop to start one element after where I is currently at. So let j equal I plus 1. J is less than nums dot length, j plus plus. So here are our two loops. Next, what we need to do is check if the value at I added to the value at j is equal to the target. And if that's the case, then we've found the two numbers that we need. And we need to return this in an array. We're going to return the indices of those two numbers. So that's simply I and j. So as far as coding goes here, this brute force solution is fairly straightforward. We'll double check that I wrote it correctly. We're passing the test cases, and we'll submit here. All right, so that does pass. It accepts and gets submitted. But notice we're not doing horrible, but not amazing on time complexity either. The brute force solution would really be bad in a situation where you were passing a very large array. Imagine passing an array with millions of numbers in it. It would take a very long time for the computer to basically go through and check every possible pair of numbers and compare all those numbers to each other. It ends up being what we call a quadratic runtime, which is not good for larger data sets. So what we want to do is switch to a more optimal technique for solving this challenge, which is called caching. And to do this, we only need one for loop here. So I'm going to delete and get rid of that inner for loop. We can leave the one that we already had. And what I'm going to need is a data structure that can save the value of each number that we've already looked at in the for loop, as well as its index. So a good way to do that in JavaScript is to simply use an object. Another way that you often see people do this challenge is using a data structure called a map. But if you haven't used actual maps yet before, an object will work just fine for this challenge. So we've got our map set up here to store our values. And what we're going to do now is we're going to create a variable called other num. And we're going to set this equal to the target value minus nums at I. So that's going to give us a variable that can allow us to search for the other number we would need compared to the number that we're currently looking at as we go through this for loop. Okay, so we're going to set up an if-else block here, and what I'm going to do, I'm actually going to handle the else condition first, because I think this will make more sense if we start with this. So as we go through and look at each value, iterating through with this for loop, if the value is not already in the map, or if we don't find the solution for it by looking for this other num in the map, what we want to do is add it to that object. So we're going to set map at nums at I equal to I. Why do we set it equal to I? Because remember, at the end of this, what we need to return is the index. So we need to store both the value of the number itself, being the key, and then the value for this key is going to be the index. So we have that saved in the object. Now we'll go back to our if condition here. So if map at other num exists in the object, we're going to check that by saying does not equal undefined. Then we can return map at other num, which is going to return that index. Remember, when we set it into the object, we made that value the index right there, and the other value we need to return is I. Okay, so this is a really powerful technique. It allows us to take that brute force solution, a quadratic runtime, and change it to a linear runtime. So I'll run this once, make sure I've typed everything correctly, and looks like we're passing those test cases. So if we hit submit, let's see how much faster it was this time compared to our previous example. So in this case, 106 milliseconds compared to 72 milliseconds, so it gets a little bit better. That maybe doesn't show exactly how powerful this can be, especially as you approach larger and larger data sets, but you do want to know that this is a much more optimal way of solving this problem rather than just doing the brute force solution. So if this was your first time looking at the two-sum problem, hopefully this was helpful for you. Hopefully this made sense. If you have any questions, feel free to let me know. Be happy to discuss and talk with you more.